The building structure is unlike any other.
The focus on mass timber was to reduce the embodied carbon.
We are building on top of Australia's largest railway station in Australia's biggest city.
This is Sydney's most challenging development site.
When compared with other structures in the world, we do not believe there's anything that compares to this building.
We actually said, no, we are going to deliver on our promises here, and we are going to deliver the building that we set out to deliver from the very start.
Jahaan Rowdah, construction manager with Built Obashi on the Atlassian Central project. The Atlassian Central's building structure is very unique and dynamic for a series of reasons. It has an external diagrid structure, steel column structure, from level 7 up to the top of the building. An external diagrid structure is not unusual, but what is unusual on this project is that load does not go down to the ground. At level 7, it transfers through diagonal columns into 2 locations, the concrete core and 2 mega columns to the north of the building. A fundamental part of the building structure is a drive to reduce embodied carbon by 50%.
My name's Peter Morley. I am the project director for the Atlassian Central development. Our traditional materials of steel and concrete, which have been used for 100 plus years in terms of high-rise construction, they are very suitable materials, right? Structurally, they are very efficient in terms of taking those loads, spreading those loads, but they also are and have been traditionally very carbon-intensive materials. That has an impact on the broader ecology of the world.
There is 7 megafloors at every 15.5 metres high, supported by a series of diagrid steel tubes and a structural steel floor plate with a composite concrete slab on top. The most dramatic of these is between level 7 and level 11, where there is a 6-metre cantilever on 2 of the 4 elevations, resulting in extreme out-of-balance loads across the building. Another key aspect of the building's design is the out-of-balance forces between the nodes located around the perimeter of the building. So on level 7, there is greater load on the eastern nodes ahead of the cantilever occurring, and then level 11, that shifts over to the western elevation. So there is a lot of out-of-balance building loads and building forces.
This is our opportunity, I suppose, to demonstrate that mass timber can be used successfully, overcoming those structural load limitations by way of the hybrid structure, which is essentially breaking the building up into a series of what we call habitats, but which are essentially 4-storey buildings stacked on top of each other.
The crown space is also a very challenging exercise for us to undertake, mainly from a logistics perspective, as the floor space or the floor areas start to reduce as each floor gets constructed. So materials handling is more difficult, logistics on the floor plate are difficult, and when we get to the top of the building, we need to remove the self-climbing screens located around the perimeter of the floor plate. The work that's gone into the finalisation of the screens, the mobilisation of the screens, the climbing of the screens and the subsequent dismantle of the screens at the end of the project is phenomenal, and the team should be very proud of their efforts. We've
stuck to that vision that Dexus was committed to delivering on this building, and rather than just taking easy routes of trying to de-specify the building, we actually said, no, we are going to deliver on our promises here, and we are going to deliver the building that we set out to deliver from the very start.
This complex and remarkable project would never be possible if it wasn't for the hard work of everyone who's played a major part in getting us to where we are now on the project.